Welcome to part 2 of Star Trek on Making Games by Year, the show where we go year by year and make a game from history you, the audience, vote for. Last time, we talked about the history and significance of the text-based Star Trek game from 1971. Now, we'll give an overview of how we implemented our version of the game. In part 3, we'll do a deep dive into some specific notable algorithms we added for this game. I want to give a summation of the work that went into this. If you're a developer and want to leave in enough info to keep your interest and maybe even code along if you're so inclined. If you're not a developer, this video is for you too. I try and break everything down so you can get the gist and follow along, and it's not important that you understand every last syllable. My goal is to have the technical parts of the show be sort of like cooking shows or Bob Ross, where you can just enjoy the ride and have fun, or if you want you can really get into the details. The first thing we need to do is pick a language and tools to make our version of the game. On this show we follow some basic rules about making our versions of the game. The first is that we always use modern technology, that way we can do it quickly. We also want to put our own spin on the game and make it our own. But in doing that we still want to keep the rough scope and feature set of the original game, so things don't spiral out of control and we still respect what was special about the original game. So I had some goals with this Star Trek game. First and foremost, I wanted to honor the original by making it accessible for modification as much as possible. I also wanted to make it playable on a touchscreen without compromising the design. When I sat my playtesters down in front of my early versions of the game as well as the original, it became apparent that I would need to change things so it was playable without a manual, and so that the gameplay was a little more about strategy and a little less about learning the interface or about random chance. It was core to the original game's identity that it was written in BASIC, in terms of how it was cloned and distributed in magazines and so on, as we talked about last time. So we want to pick something that's a spiritual successor to BASIC in those aspects. Making the game a web page with HTML and CSS, and using JavaScript for the game code, is about the most accessible you can make a program. Anyone who ever did code on MySpace or Tumblr, or has ever just accidentally clicked show source in their browser will understand that the code is just right there to look at and modify. Additionally, this means there's no need to download a suspicious executable or an app, and this also means people can click a link even on their phone or in their Facebook feed and just be playing the game right there. This was an important goal for me since I thought that for a game of this scope, that's how people would actually want to play it. It's not my favorite language, and I had very little experience with it going in, but based on these criteria, it is the right tool for the job. So for anyone who doesn't know, you can think of HTML as the actual content and structure of a web page, such as paragraph, text, images, links, and so on. And the CSS manages the look and feel of a page, the style and layout. These two work together. Then we have JavaScript, which is a full-fledged programming language. This will run under the hood of our web page, and that's what we'll actually write our game code in. This approach had pros and cons. First, the good. To write the code, all you need is a text editor. I used Visual Studio Code, which is free, but any text editor you have will do. Additionally, your web browser is all you need to actually run the game, and it doubles as your debugger. I use Chrome. Chrome's debugger has a device simulator that let me tweak and debug layouts on different screen sizes and devices, including tablets, iPhones, and Android phones. To publish the game, I just configured my GitHub repository as a website using GitHub Pages. You can easily do this yourself for free. As far as the drawbacks go, I did have a bit of a learning curve, and I spent a lot of time on Stack Overflow dealing with the quirks of the language and just fiddling with the CSS. Here's something I wanted to share that not everyone might be aware of. If you open a link in Facebook or Facebook Messenger on your phone, it opens a web page in its own browser rather than whatever your browser of choice is. When I was finished with my game, I sent out the link to my playtesters after everything worked on all my browsers and devices, but then randomly all my testers were telling me that the text was way too tiny to read. It ended up being an issue only in the Facebook browser that I had to track down and work around. So pro tip, make sure you test your page on the Facebook browser. You can kind of think of it as the new Internet Explorer. It's a browser more people are using than you think, and it's the one that always has an unexpected problem. On to actually making the game. I did a mock-up of the layout in CSS and HTML before I even wrote a single line of game code. The original game was designed for a teletype, so it would just keep printing and printing as you play. To make things a little more modern and browser-friendly, I decided early on to commit to a single screen that updated instead. Here's a simplified outline of the user interface in HTML. You can see there's 3 main sections. You have the map and status on top, you have the text area output in the middle, and you have the menu and input on the bottom. Note the use of the HTML div tag. A div is just a content division, or the way we divide our content into sections and subsections. You have a text area for the scrolling game output, and 2 HTML input elements, the button and the text box that you type into. Everything else is pre-formatted text generated in the JavaScript code and injected into divs. We align some divs horizontally, like the map and the game status. We do this by setting the display property of the CSS for the div to the inline block value. At the bottom of the screen, you have the menu and inputs. The overwhelming majority of the interactions can be executed just by selecting a numbered item from a menu. So to facilitate this common scenario, we have a menu class in our JavaScript code. Our menu class just encapsulates a prompt and a list of options to choose from. Each menu option itself is an object that encapsulates a bunch of fields that make the menu actually work. You can think of these as the grammar for the menu. The option field is what the user actually types in to select the option. The description just says what it is. In between, you have a separator, like the parentheses here. The enabled flag says whether we should show the option on the menu at the current time. This is for context-sensitive options, like bombarding a planet or docking with a starbase, which require you to be adjacent to the target. The payload field is simply an arbitrary function that executes when the option is selected. This can do anything at all that we need, including changing to a different menu. The menu class has an input handler that chooses and executes an option based on the user input. The game state captures input and forwards it to its own input handler, which we can assign to any of these menus. With this, we can handle the overwhelming majority of the input in the game. The fact that most of the input can be done through the menu class is really convenient for updating the game to not require so much typing on mobile devices. We can just hide the button and text box and make the menu options themselves hyperlinked. We can have the hyperlink called JavaScript code that forwards a text string the user would have had to type in to the game input function. There's a few cases where we can't just pick a menu option off a list. For example, entering the shield level, entering navigation coordinates, or setting the phaser energy when we fire weapons. We have custom input handlers for all of these cases. For the touchscreen version, we handle each of these cases separately. For setting the shield and phaser energy levels, we make a special menu that has reasonable values the user might want, and we have a menu option that lets them bring up the typing interface as a fallback in case they don't like any of those options. That way we don't lose any of the flexibility of the old school version. When we want to do short-range navigation, we make the squares on the sector map hyperlinked, so you can just touch or click the subsector you want to travel to. For long-range navigation, we make an interactive galaxy map that additionally shows sensor information about a sector when you click on it. These changes let us have an interface that's streamlined but doesn't compromise anything over the typing version. Earlier, we said that when we make our own version of the games on the show, we want to improve them and make them our own. I affectionately call this the Babish version of our game. The touchscreen interface we're describing was the first of several changes I wanted to make. Along the way, we made a ton of quality of life and playability improvements in the game design that would take too long to go over individually, but most obviously, we display the options and the map key at all times on screen, and we keep everything on a single updating screen. These changes made a massive difference in how quickly my playtesters were able to catch on to this game. There's also the Mirror Universe gameplay mode. I really like that episode of the show, and it's always fun to have an evil option in games. Plus, it kind of resolves the tension between the gameplay and the story of the original game. In the backstory of the original game, you're supposed to be stopping a Klingon invasion and defending your star bases, but since there's no AI really to speak of, in the actual game, you're really hunting down these inert enemy ships and destroying them. There's some different text and a different story, and your crew members can throw you in the agonizer booth for a star date if you destroy a friendly starbase. The only real gameplay change is that we add a planet mechanic. In the Mirror Universe version of the game, you can stumble across a planet, and you can bombard a civilian target with torpedoes. That's a fun way to be the bad guy, but it also can stir up the hornet's nest and get enemies to come to you. This can be a tactical advantage if you're running out of star dates to complete your mission. Most of the changes in the code are cosmetic, outside of the planet mechanic, but I thought it was neat. The final major improvement we make is the Autosave feature. This lets you close your tab or minimize your browser and come back and pick up where you left off. In order to do this, we convert our game state into JSON. For those of you who don't know, JSON is just a representation of our game data as text. It's stored in pairs of keys and values, and it looks something like this. Once we have the JSON, we use the local storage feature of JavaScript to save it into the browser cache. When we load the save game, we reconstruct our game from this saved data. On a more technical note, the JSON only stores key value pairs, but we use classes with inheritance in our game code. So when we load the autosave, we have to do a little bit of extra work and finessing to make sure that we get back all the correct types and make sure everything works well together. The game has a splash screen that'll let you continue your previous save and configure these options of whether you want the touchscreen interface, or if you're a purist and you want the typing interface, and it'll also let you decide whether you want the prime timeline or the mirror universe. From the splash screen, we just pass these preferences to the game HTML, and then the game code itself will do the appropriate setup to let the users start playing the game. Now that we've talked a lot about the interface and improvements we made, we can talk about the actual game code and simulation underneath it all. All the input options we described earlier let the user choose actions that ultimately affect the state of the game world. You can describe and model all of these actions with a chart. All of these actions can take some amount of energy and some amount of time, and some of them give the enemies an opportunity to fire while others don't. Our game world is made up of different game objects, all of which derive from our game object base class. This base class does a ton of things for us. In order to make a new type of object we want in our game world, we simply inherit from game object and override whatever methods we need. The class for the star object is a great example of how easy this can be, since the stars basically do nothing in the game. So in order to create the star object type, we just extend game object, and we have to override the toString method to return the text that the map screen will display. Pretty much everything else will just work with same defaults. Game object also has overrideable events for more complicated objects, like we want the Klingons to be removed from the game when they're hit by a torpedo. We could hypothetically extend the game with additional events in the future to make the game world much more responsive. All of these objects are situated in our game world, aka the galaxy map. The galaxy map is just a grid of sectors, and each sector is just a single screen of the game. Each sector is itself a grid of subsectors, or a space where a game object could go. We have a grid-based class, which does things like help us look up or set values, use a function to initialize cells, find an empty cell location to put an object, print the entire grid as text, and so on. Without getting into the nuts and bolts of specific algorithms, which we'll do next time, that's the basics of our game objects and our game world. But I would like to talk a little bit more about our most complicated game object, the Enterprise itself. The Enterprise tracks a sensor history. For each sector, we just keep track of the number of each object type that we've seen. This information comes from long-range scans done by the Enterprise and by friendly starbases. This information is useful for finding interesting places to navigate to. When the Enterprise is hit by enemy fire, it has a number of ship components that can be individually damaged and affect the gameplay. Each component is defined by a subclass of ship component, so in addition to its specialized behavior for each component type, it encapsulates a name, a health percentage, and the probability of being hit, since we want different components to be more or less likely to be hit. These components have different effects or even multiple effects as they degrade, but my favorite was having the short-range sensors slowly corrupt your map as it degrades, sort of like how the view screen would get corrupted on the show. That's it until part 3. In the meantime, you can play the game and check out the GitHub. The full commit history of the code is on the GitHub if you want to see how this code was written step by step. If you have any questions at all about this game or the code, go ahead and put them in the comments. I wanted to give an overview of what I actually did without being too jargony or technical, or losing all the people who just wanted a general overview of how this game was made. So I'm trying to find this balance, and in the meantime, I appreciate your feedback. So thank you for watching, and I'll see you next time in part 3, where we'll go over the specifics of the new algorithms we introduce in this game. See you next time.